Hello. Prove that one of three consecutive numbers is divisible by 3. Let's have these numbers as n add 1, and n add 2. So we'll start with n. Now, if it's divisible by 3, the remainders, and this is based on the algorithm, the division algorithm, the remainders, you look at my previous videos, I've gone through explaining what the division algorithm is. The remainders are 0, 1, and 2 for division by 3. And we're going to use congruences here. So if n is one of the numbers we start with, then n, and it's divisible by 3, is congruent to 0 mod 3, which indicates that there's no remainder, which means that it's divisible by 3. So this implies that n is divisible by 3. What about if we have n congruent 1 mod 3? So now if we add 2 to both sides of this equivalent sign, we have n add 2 is congruent to 3 mod 3. And we do know that further to this, in fact, we can write this in the same line here. Now we're looking at 3 is congruent to 0 mod 3. Now this is indicating that 3 minus 0 is divisible by 3, which is true, so there's no remainder, indicating that n add 2 is divisible by 3. So we have conclusion that this implies that n add 2, which is what we started with here on the left, is divisible by 3. And lastly, if we put that n is equivalent to 2 mod 3, then that implies that if we add 1 to each side of this congruence, and add 1 is congruent to add 1, which is 3, which again is congruent to 0 mod 3. So we have n congruent to mod 3. We add 1 to both sides of this congruence, and we have n add 1 is congruent to, or equivalent to 3, which is congruent to 0 mod 3, which again indicates that n add 1 is divisible by 3. So we've shown here, we've proved that n, in this first case, n add 1, so we have n here, we have n add 1 in this case here, is the last one here, and n add 2, all three of these are divisible by 3. using congruences. Thanks for watching. I'm Alistair.